Chapter 5, Section 2, binomial factors. I'm just going to show you what they are instead of trying to explain it. So here I have a binomial, and well, it actually doesn't ask us to factor it. It just asks for the GCF, the greatest common factor. 7 and 6, there are no common factors. X, Y, Y, the best I can do is Y. And this GCF, the Y, is a monomial. Okay, that's all it asks us to do. The next one, 9AB minus B. Okay, the GCF is just B. Okay, and again, it is a monomial. Okay, up until now, all of the factoring that we've been doing have involved factoring out a GCF that is a monomial. Okay, well, this one here is a little bit different. I have a 7x times y minus 3 plus 6 times y minus 3. Now, whenever you see a bunch of stuff in brackets, in this case a binomial, think of it as one item, like a basket of food. You think of it as one basket as opposed to all the individual food items inside. All right? So, in fact, the greatest common factor is the y minus 3. Okay? Because both of these terms contain a y minus 3. This has a 7x, this has a 6. There are no common factors there. So the y minus 3 is the best that we can do. But in this case, the GCF is a binomial. But you can treat it as if it's one thing, one term, so to speak. Let's do another one. 9a times b plus 6 minus b plus 6, all in brackets. Okay, well, we have b plus 6 repeated. That is the greatest common factor. And again, it is a binomial. So this is what's a little bit new. Now we actually want to factor something. So x times x plus 2 minus 5 times x plus 2. Okay, in this case, the GCF is a binomial. It is x plus 2. But I'm just going to treat it as if it's one number. Okay, one set of brackets. Okay, and we're going to do exactly what we did before when we factored. We divide out each term by the GCF. So we write the GCF in front, just like we would before. It's just a binomial inside a set of brackets. And then we write whatever's left. Well, if I have x times x plus 2, and I've divided out the x plus 2, only the x remains. Okay? In the next term, I have a minus 5 times x plus 2, but I factored out that x plus 2, which means this is just 5. So x plus 2 bracket x minus 5. This is now factored. Let's try a different one. Okay, looking at all this junk here, the GCF clearly is x minus 1. So that is what I'm going to factor out of everything. So I'll write that out here. And then what's left? The 4x and the 3. And with that, we're done. Now hopefully you notice that in questions such as this, in the end, we end up creating a product of two binomials. Whereas before, when we were factoring, we would have just a monomial here out in front, and then we would have a binomial or a trinomial over here. So really the only difference now is that the GCF that's now in front is a binomial. All right. Factoring by grouping. Okay. As we work through these problems, we're actually going to apply the technique that I just showed you. Notice we have a polynomial, but it's 4 terms, and there are no like terms, so I cannot simplify this. Okay, so normally we would look for a GCF, okay, a common factor that is shared amongst all 4 terms. But if you look at 12, minus 4, 15, and minus 5, there are no common factors there, okay? This has an a squared, this has an ab, this has an a, this has a b. Okay, so I can't factor out any a's or any b's. So you may think this is not factorable. Well, there's another type of factoring that we can look for, hence by grouping. And I'm going to color code them. It's like I'm splitting this problem into 2 pieces. what I'm going to do is I'm going to factor out just this first set of two terms, so this binomial right here. This has a greatest common factor of 4a. And then what's left would be 3a minus b. Okay? And now I'm going to move on to the next group. What's the greatest common factor between 15 and the minus 5? Well, that would just be 5. And a, b, well, there are no common factors there. So the best I can do is to pull out a 5. If it's a positive 5, I must put that plus there. Okay? And then I'm going to write what's left. And I get 3a minus b. Hopefully you notice something. These binomials right here are the same. Okay? And I showed you how to factor polynomials that look like this. Let's put this, keep this in black. All right. So the 3a minus b can get factored out like so. And then I write what's left. And that would be the 4a plus 5. Okay. So in the previous problems, I started here. Okay, and then we just went this final step here. So the only thing that's different with these three questions is we have to create this line right here from the beginning. Let's do a few more. In the next example, I have x squared minus 2xy plus 3x minus 6y. First step is we always look for a GCF that works for all four of these terms. And I can tell by looking at them, there isn't one other than 1, which doesn't really do anything. So now I'm going to move on to this grouping technique, and I'm going to try and factor these two binomials within this polynomial. So the GCF in blue, the best I can do is factor out an x. Therefore what's left is x minus 2y. And when I factor this set in red with any luck, in brackets, I'm going to get another x minus 2y. Let's see if that happens. 3x minus 6y. Well, the best thing I can do is factor out a 3. It's positive, so you have to put a sign here, or an operator. And that would be x dividing by 3. That gives me minus 2y. Huh. What do you know? It works. These two are the same. So that is my new GCF, only it is a binomial. So that gets factored out. I get x minus 2y, and then I write whatever's left. So that was the x plus 3. That one is done. Okay. Next one, y squared plus 8xy minus 2y minus 16x. Okay, there's a little asterisk here. That doesn't really mean anything mathematically. It's just a little flag to indicate that we have to be a little bit more careful with this question. And I can see already it's because of the signs. All right, so I'm just going to put a little divider here. Okay, so look at all four of these terms. Nope, there's no GCF that works for all four of those. So we move on to this grouping technique. Okay. Right, so in blue, the GCF here is just y. Therefore, what's left is y plus 8x. Now, for this to work in the end, we want to be able to create a red set of brackets that says y plus 8x. Okay, so I have minus 2y minus 16x. Okay, well you might think you can pull out the 2, but that would leave a negative y minus 8x. That's not quite what we want. Okay, well we can get around that problem by, instead of factoring out positive 2, we can factor out a negative 2. Okay. Okay. And that will reverse the signs of all of these. So this becomes positive, and this becomes positive. There we go. Now they match. So if it looks like it's going to work, but you're running into problems with your negative signs, just factor out the negative and see what happens. In this case, it worked out. So I get y plus 8x times, and then what's left over, y minus 2. Okay. Well, remember before, when I first introduced factoring, I said you can always check to see if you did it right, meaning you can always multiply everything back out again and see if you end up back where you started. So my final answer here was a product of two binomials. If I multiply them out again correctly, if I get this polynomial back again, then that means I did everything right. When you multiply two binomials, the quick trick is FOIL. First, outside, inside, last, which is just a special case of the distributive law. So that's what I'm going to do. Keep that in black. So I get 3a minus b and 4a plus 5. And I'm not going to draw the little arrows or the rainbows. I'm just going to do it straight. So the first two terms multiplying, I get 12a squared. Outside gives me positive 15a. The inside, that's going to give me minus 4ab. You might choose to write it as ba, but I always like to keep the letters in alphabetical order. And then the last two terms, minus b times positive 5 is minus 5b. Quickly check for any like terms. There are none. Now let's compare it to the original. And well, it looks good. These terms here are in different order, but as long as their signs match, we're good to go. So no problem. Let's verify that this product of binomials is in fact equal to this polynomial up here. So x minus 2y times x plus 3. Let's multiply them out. So this gives me x squared plus 3x. That's from the outside. Inside, minus 2xy. And the last gives me minus 6y. Quickly check. There are no like terms, and I believe that is what we have up here. Yes, we do. Again, the middle two terms are in different order, but the signs match. We're all good. Check the last one. Y plus 8x times y minus 2. Okay, so this gives me y squared minus 2y. Inside is plus 8x. Y. Last is minus 16x. No like terms. Do a quick comparison, and perfect. So these are all correct.